Hello and welcome to our channel IPM Leap. Today's video lesson is about the question type you can see on your screen. Now, even though I can't see your reaction looking at these questions, but from my teaching experience, I know that most students find these questions scary. Scary to the extent that they don't even attempt them in question papers. But as a matter of fact, these questions are not that tough. They can be solved easily using a simple trick. I assure you that once you learn that trick, you can solve these questions within seconds. Just grab a pen and a notebook to take notes as we go along this lesson. And once you have done that, let's discuss. So friends, first thing to note in these questions is that there is a recurring pattern. The same number 30 with a plus sign is getting repeated over and over again under the square root radical till infinity. Now these series are known to be converging series, which means if you take a sufficient number of these repeating square roots, then the value of this series converges to a certain number, and increasing one more square root sign from there on will not really increase its value. There will be a very small or insignificant increase which even a calculator cannot measure. So the trick works like this. We assume the value of this expression as x. And since one term does not make any difference to an infinite series, if this is x, then so is this expression. So let us substitute this encircled expression as x. And we get the equation under root of 30 plus x is equal to x. Squaring both sides, we get 30 plus x is equal to x square. Now this is a quadratic equation and very likely it will have roots that are integers or at least rational numbers. That means we can factorize this expression. The factors will be x minus 6 into x plus 5 is equal to 0. So either x is equal to 6 if this term x minus 6 is equal to 0, or else x should be equal to minus 5 if x plus 5 is equal to 0. However, square root of any number, as you can see in the original question, is always a positive value. Therefore, x cannot be equal to minus 5 and this expression is essentially equal to 6. So the method wasn't too difficult, was it? Let's try out a few more questions. Our next question has a minus sign instead of the plus one. That does not make a difference to our approach though, because we can see the pattern square root of 6 getting repeated over and over again. So if we assume the value of this expression as x, then dropping one term doesn't make a difference. This encircled expression is also x. So let us substitute it as x. Under root of 6 minus x is equal to x. Therefore, squaring both sides, we get 6 minus x is equal to x square. This is again a quadratic equation which simplifies to x square plus x minus 6 is equal to 0. Let us find its roots. The factors will be x plus 3 into x minus 2 is equal to 0. I'm soon going to publish a video on how to solve quadratic equations. So do watch that video if you need some help with finding roots. As of now, in our quadratic equation, if this term x plus 3 is equal to 0, then x should be equal to minus 3. We know that is not possible because in our original equation, we had a square root of something which is always positive. So if x minus 2 is equal to 0, then x is equal to 2 and that is our answer. Please note a very important point here. The moment we square an equation on both sides, as we did at this step, we introduce an artificial and extra root which will not satisfy our original question. Both roots are not our answer, so be cautious. Whatever roots you get on solving the quadratic equation, just reason it out as to which one can satisfy the original equation and which one would not. Let us move on to our third question. Square root of 3 times square root of 3 times square root of 3 times square root of 3 up till infinity. There is no plus or minus sign this time, but remember, if the plus or minus signs are missing, that means these numbers are getting multiplied together. The simpler approach to solve these questions is exactly the same as what we did in the previous two questions. We assume this expression is equal to x. Now, as this expression under the square root extends infinitely, then this encircled expression would also be equal to x. So we can safely replace it with x and we will get the equation under root of 3x is equal to x. Squaring both sides, we have 3x is equal to x square, which simplifies to x square minus 3x is equal to 0. Finding roots of this quadratic equation is very simple, as you can take x common and the two factors are seen clearly. They are x into x minus 3 is equal to 0. This implies either x is 0 or x is equal to 3. But how can this original expression with proper numbers be equal to 0? It can't be. So that means this expression will be equal to 3. Now for the same question, there is an alternative approach which I will discuss next. This approach will help you solve a slight variation to this problem. So as I told you earlier, no sign, no plus minus sign means these numbers are being multiplied together. 3 with a square root sign means 3 raised to the power of half. Multiplied with number 3 with two square root signs over it. It means 3 raised to the power half whole raised to the power of half. Next, we have 3 with effectively 3 square root signs over it, which means 3 raised to the power of half, whole raised to the power of half, whole raised to the power of half. And since a raised power of m whole raised power of n is equal to a raised power of m into n, the net powers will be 3 raised to the power of half, 3 raised to the power of half into half, which is 1 by 4, and 3 raised to the power of half into half, which is 1 by 8, and so on. Also, we know that a raised power of m into a raised power of n is equal to a raised power of m plus n. The powers get added up. So in this expression, 3 raised power half into 3 raised power of 1 by 4 into 3 raised power of 1 by 8 into 3 raised power of 1 by 16 and so on up till infinity, powers get added up. Net power of 3 will be half plus 1 by 4 plus 1 by 8 plus 1 by 16 plus so on up till infinity. Now this is an infinite geometric progression with first term a is equal to half and common ratio denoted by r is equal to half again. The sum of an infinite GP where the common ratio is less than 1 is given by a upon 1 minus r. So let us substitute a as half and r as half in this formula and we get the sum of this infinite series as 1 by 2 over 1 minus 1 by 2, which is equal to 1. Net power of 3 in this expression is 1. So this original expression will be equal to 1. The value of this expression is 3 raised power of 1, 3 itself. Now I don't see any reason why anybody, including me, will prefer this method over the previous much simpler method, right? Don't you think so? It is only when you face questions like question number 4 when this method seems more useful. In this recurring series, there are a finite number of terms, not till infinity. So we can't say that if this overall expression is x, then this nested radical sign under it should also be x. That will be wrong to say. But this alternative approach is 100% correct even for these questions. Adding up the powers, we get 5 raised to the power of half plus 1 by 4 plus 1 by 8 plus 1 by 16. And yes, this is a geometric progression. Yes, there is a formula for sum of a geometric progression as well. But why bother? How much time does it take to add up 4 terms? These are 4 terms, right? 2, 4, 8 and 16. The LCM is 16. Numerators will be 8 plus 4 plus 2 plus 1, which is equal to 15. So this expression is equal to 5 raised power of 15 upon 16. Moving on, our next question is square root of 3 plus 2 times square root of 3 plus 2 times square root of 3 plus 2 times square root of 3 plus so on up till infinity. Looks slightly more complicated, but actually it is the same. There is the number 3 and there is the number 2. But notice the pattern. It's a recurring pattern. Square root of 3 plus 2 times and this whole expression repeats. So we will take our earlier approach. Say this expression is equal to x. Then this encircled expression is also x. Let us replace its value as x. Square root of 3 plus 2x is equal to x. Squaring both sides, we get 3 plus 2x is equal to x square. The quadratic equation is x square minus 2x minus 3 is equal to 0. Its factors will be x minus 3 into x plus 1 is equal to 0. And therefore, either x is equal to 3 or x is equal to minus 1. But as we have seen earlier also, anything under the square root sign is essentially positive. It cannot be negative. So we drop this value of x minus 1 and our answer for this expression is x is equal to 3. And our final question is just the reverse. Inside this infinite nested radical, we have the variable x. We have to find the value of x and the value of this overall expression is given to be 10. The approach remains the same. If this is 10, then the value of this encircled expression is also 10. We replace its value and we get the equation square root of x plus 10 is equal to 10. Squaring both sides, we will have x plus 10 is equal to 100. And transferring 10 to the right hand side, we can conveniently get the value of x as 100 minus 10, which is equal to 90. So this expression is equal to 90. We tick that value in our options list. So that brings us to an end of this video lesson. Hope you like this video. Don't forget to press the like button and subscribe our channel for more such useful content related to exams. Keep watching and take care. Bye-bye.